Hello students, welcome to e-learning. Today we are going to start with unit number 4, bending moments and shear force, lecture number 32. In this we will talk regarding or we will discuss regarding simply supported beam, how to find out or analyze shear force and bending moment. So first, a simply supported beam of length 6 meters carries point load of 2.5 kilonewton and 4 kilonewton at a distance of 2 meter and 4 meter from left support respectively. Draw shear force and bending moment diagrams for the beam. So you can see here a line diagram is given along with the question. They have said that the total beam length is 6 meters, then point load of 2.5 kilonewton and 4 kilonewton are acting at 2 meters from left support and 4 meter from left support respectively, right? The total span is 6 meters here. So now first and foremost thing, we need to take out or calculate reactions, because these two supports, support A and support B, are going to have reaction for these action loads. These are active loads, right? So these downward forces should have resistance or should be given support to balance. That is why two reaction forces are acting, that is reaction A and reaction B. So next we will try to calculate taking force acting on the beam, that is 2.5 plus 4 kilonewton. So it is going to be 6.5 kilonewton action acting on the beam, okay, and reactions also should be equal. Action and reaction should be equal, that is why RA and RB is equal to 6.5. So because action is equal to reaction, so action is 6.5 kilonewton, so reaction also should be 6.5 kilonewton, so that should be equal to RA plus RB. Now taking moment at point A, okay, reaction B is going to rotate the beam in anti-clockwise direction. So RB into perpendicular distance till A is nothing but 6 meters. So that is what it is written here, RB into 6. Okay. So that is reaction moment. Okay. Reaction B, moment towards A. So is equal to 4 downward force. You can see there 4 kilonewton is acting in clockwise direction towards A point, 4 meters. So 4 into 4 meters. So that is clockwise moment towards A, plus 2.5 is acting downwards anti-clockwise like this, right? So it is going to act in this fashion. So load into perpendicular distance till A is 2 meters, right? So this is what it is written here, 4 into 4 plus 2.5 into 2. So 6 RB is equal to 21 kilonewton meter. So you just keep RB on the left side here, and 21 divided by 6 you can shift it below in the denominator. So 21 divided by 6 is equal to 3.5 kilonewton. So we got reaction at B. So this reaction value or the reaction load or reaction force is 3.5 kilonewton. Coming to next, we know action is equal to reaction we have taken. So here this equation is taken, RA plus RB is equal to 6.5. Put value of RB, okay, so that is 3.5. So you just take out 3.5 towards right side, you are going to get reaction reaction at A is equal to 6.5 minus 3.5 is equal to 3 kilonewton. So RA is 3 kilonewton and RB is 3.5 kilonewton. 3.5 kilonewton. Okay. So next, after knowing these two reactions, we will go for shear force calculation. So shear forces. So we have this drawing, shear force calculation. So shear force at B, always shear force at B will be reaction at B, and shear force at A will be reaction at A. Okay, you can see here reaction at A and reaction at B are the reaction forces. So reaction at C, reaction at D is not calculated, you can find it out. Okay, so reaction at C is here, sorry, shear force at C, not reactions, shear force at C. So shear force at C will be minus 3.5 plus 4, it will be 0.5 kilonewton, or you can go for another calculation, that is shear force at right of C first and then shear force at left of C. Okay, so when you stand on the right side of C, you will have only reaction acting, and when you stand to calculate shear force at left of C, you will have reaction force, because there are two forces acting for the point C when you stand on the left side. So reaction at B minus action load, that is 4 kilonewton, you will have the calculation as 0.5 kilonewton. Then coming to shear force at D, shear force at D right, the same thing again, it will be 0.5, because there are, when you stand on the right side, you will have two loads acting, one reaction and action force, so it will be 0.5 again. Now shear force, when you stand on the left side of the point D, you will have reaction force 4 kilonewton and 2.5 kilonewton, so it will be 0.5 and plus 2.5 kilonewton, so it will be 3 kilonewton here. So this is how you have to calculate. So reaction at D, this should be reaction at D. Okay, same thing, reaction at A will be again same 3.3 kilonewton, because shear force is equal to reaction at that particular support. So this is the shear force calculation. Now bending moment calculation. First and foremost thing, moment at support. Okay, moment at B and moment at A will be always 0. Okay, in simply supported beam only. So in simply supported beam, the reactions or the moment at support will be always 0. Now moment at C, if you want to take moment at C here, take only right side consideration, loads which are coming from right side. So reaction force is acting, this is acting, the force into perpendicular distance till C, because we are taking moment at C, right? So it will be 3.5 reaction into this distance, that is 2 meters, because 6 minus 4 you will remain with 2 meters. So it will be 3.5 into 2, that is 7 kilonewton meter. Coming to next, bending moment at D. So all right side forces you have to consider. So a reaction into this distance, that is perpendicular distance, so 3.5 into 4, because 6 minus 2, the remaining distance is 4 meter, minus 4 into 2, so this is the perpendicular distance, this is force and this is perpendicular distance till D. Coming to next, it will be moment at A. So moment at D is calculated just now, that is 6 kilonewton meter. Moment at A is always 0. The calculation is shown here. You can see 3.5 into 6 minus 4 into 4 and minus 2.5 into 2, right? So this is how shear force and bending moment calculation is done. Next we will see how to draw the diagrams, shear force diagrams and bending moment diagrams. So you can see this diagram is shear force diagram and this diagram is bending moment diagram. So how to start with? After knowing all the points A, D, C, B in the line diagram, project those all lines below, okay, and take one reference line for shear force and bending moment reference line at the bottom. As considering positive and negative values, just take the reference line with common sense, left and right or bottom, okay. So next we will take the shear force diagram. So shear force at B is minus 3.5. just mark the point below because it is minus, negative value. Coming to next shear force at C, it is plus 0.5. just mark 0.5 because there is no load between C to B. Just go horizontal and just pull it till 0.5. Then coming to next shear force at D, it is again 3 kilonewton. So as there is no load between C to D, just take this 0.5 till D in the same straight line. Then coming to next shear force at A, shear force at D, it is 3 kilonewton. So mark this 3 and end it. So join all the lines with the marked points and you will get the shear force diagram. Similarly, you have 4 points for bending moments. Bending moment at support, that is A and B, it is 0, 0. Then bending moment at C is 7 kilonewton meter and bending moment at D is 6 kilonewton meter. So marking all those points, because all those values are positive, it will be above the reference line, okay. So next thing, after marking, join all those points of bending moment at that particular or respective locations. So this is how you have to finish up with calculation of shear forces and bending moment and its diagrams, okay. So positive and bending here in this simply supported beam or in all simply supported beams, you will get positive bending moments and shear forces positive and negative. So thank you for careful listening, patient listening. For further notifications and upcoming videos, please subscribe the channel Diploma in Civil Engineering Pratik Lohar. Also like, share and comment. Thank you.